Hello and welcome to this final project presentation for a course in cloud computing. The project title was AWS Redshift. And the motivation to select this topic was my experience with SAP BI tool, which is a pretty sophisticated one, that required developers to go through a complex series of processes to create and populate a data warehouse, aggregated cubes and data marts for BI analysis reporting. Redshift provides a fully managed petabyte scale data warehouse capability in cloud that is very simple to set up and run. Very reliable with highly reliable fault tolerance to replication of data. It is very secure to encryption of data at rest and transition. It is very scalable, scaled from hundreds of gigabytes to petabytes using massively parallel processing power. Compatible with other AWS services, fully integrated with internal AWS services. Provides a strong business and technology case where the cost is roughly 1/10 of the traditional on-premises solution. It allows for leveraging investments in existing BI tools and allow customers to have their own internal virtual network using VPC, control access to their Redshift resources, and define their own firewall rules, etc. The project was implemented first. You started with reviewing and studying the literature for the understand the benefits and features and underlying the technology of that Redshift offers, and then launching a cluster using Redshift console, installation of the tools and the drivers to connect to Redshift, and creating a data warehouse fact tables and dimension tables with a star schema, loading sample data from S3 bucket to Redshift and running sample queries on them. And afterward, reviewing and capturing the loads, the queries, and the query plan, the data loads performance of the CPU utilization, GPU utilization, and so on. Resources used was Windows 7 64-bit with Java 7 runtime environment installed, Redshift for data warehouse, and S3 for data staging, SQL Workbench to connect to Redshift, creating tables and performing queries, and AWS Redshift documentation, of course. Redshift architecture to support massively parallel processing for faster query processing. At the heart of that is a cluster made up of vast array of computing nodes. These computing nodes are in turn connected to a leader node. The external SQL clients, they connect to this leader node only through JDBC and ODBC drive. They have no direct connection to the compute node. The compute nodes are made up of multi-core processors. Each core is known as a node slice. And the nodes are connected to high-speed internal network using their own custom protocol. And also the databases reside in these compute nodes. The internal architecture and the system operation shows that the leader node, it will manage the communication of the external SQL client with the compute node. It will manage their communication and coordination of the compute nodes. It will parse and develop the query execution plan, compile and distribute the compile nodes codes to compute nodes. It allocate the data to the compute nodes. And the compute node in turn will receive and execute or compile code and send the intermediate results to leader node for aggregation. You could create a data warehouse in Redshift in fairly 5 simple steps. You launch the cluster, you provision the cluster, you connect to the cluster and create data tables within the cluster, you upload the data from S3, and then you perform your data analysis queries. That's it. In our case, we used an available data about a sales transaction of a series of events that has 2 fact tables and 5 dimension tables as shown in the slide. And to create the table, we used a standard SQL create command, but for loading data, Amazon recommends that we use the native SQL copy command, but you have to provide your access key and your secret key to get the permission to transfer data from S3 to Redshift. And to run the query, you can use the standard select command to get your data output. Overall experience, installation of the SQL Workbench and the drivers, creating the cluster and connecting to the cluster was pretty straightforward. But what was a bit challenging was creating the tables and uploading the data using SQL Workbench. Because between the creation of the tables and the data load, there was some idle time. During the time the connection would drop and there would be an error message, and I had no clue what that meant. I would go to the internet and try to make a sense out of it, but I was not getting any direction. So I decided to disconnect the connection window and reconnect, and that seemed to have worked. Also trying to find some information, the information that you're looking for in an Amazon Forrester documentation. There's so much out there. Was a bit challenging. What was inconvenient, of course, the frequent disconnecting and connecting the connection window SQL Workbench was disconnected. Overall, I really enjoyed working on this project, and I invite you to watch my detailed presentation in the 15-minute video that I uploaded on YouTube. Thank you for watching.